And we go to the second heat treatment, pasteurization. The name of this process is taken from the name of a scholar, of a scientist. What is his name? Louis Pasteur. Okay. He's very popular. Several names of streets in Vietnam are according to his name, several institutes and so on. Okay. And what are the objectives of pasteurization? The very first objective is to destroy pathogenic microorganism, but not the spore, but the what? The vegetative cell. The vegetative cell are pathogenic microorganism that we need to destroy to make a safe product for consumption. That's the first objective, is to make a safe product by destruction of vegetative cells, a pathogenic microorganism. And because we do heat treatments, of course, we then can also destroy a main part, an important part of spoilage microorganism. Then, because of that, we can extend the shelf life of the product. But because we do not destroy all, so we only extend limitedly the shelf life, not very long. Okay. For example, after pasteurization by heat, we have to keep our milk in a fridge. We have to preserve in chilling condition, and then we can only keep for like 7 days to maximum 10 days only. Pasteurization is an indirect heat treatment. So we call it indirect because there is no contact between heating medium and milk. But there is a heat exchange either through the wall of the heat exchanger or through the packaging material. No direct contact between, for example, hot water and milk. No. That's why we call indirect heat treatment. The process can be carried out either in batch or in continuous way. Pasteurization can be a final processing step, but can be an intermediate step. When we make pasteurized milk, then pasteurization is a final step. But when we make yogurt, then pasteurization is an intermediate step. Why thermization is not a final step, but pasteurization can be? Why thermization cannot be a final processing step, but pasteurization can be a final processing step? Because pasteurization produces a safe product for human consumption. Thermization, no. It does not make a safe product. It just gives us a short storage time for raw milk. And the indicator enzyme is phosphatase. This is the enzyme serves as the indicator for pasteurization. Indicator means it will indicate for something. Okay. So why people take this enzyme as an indicator? Because once we already inactivate this enzyme, then we assure that we destroy the pathogen that we wish to destroy to make a safe product. Remember the name, phosphatase. Now we look, you already studied food engineering. Heat treatment is a process with a combination of how many parameters? 2, temperature and time. Now we explain why this enzyme is used as an indicator. Heat treatment is a process again with 2 parameters, temperature and time. If you can do at higher temperature, then you can shorten the time, right? This is the principle. And if we look at this graph, we see this pink line is the destruction line for coliform bacteria. So either you do here 70 degrees C for 1 or 2 seconds, or you do 65 degrees C for 10 seconds, you destroy the same level of coliform bacteria. Here you have typhus bacteria that cause infection, tubercobacilli, the one that cause tuberculosis là bệnh lao á, bệnh khá là nguy hiểm nha. And then we look at the inactivation curve for phosphatase. When we already inactivate all phosphatase, means that we have to do the heat treatment on the right side of the curve, right? Have to do somewhere here. When we do here, mean we already destroy all this group of pathogen that we wish to destroy. This enzyme is used as an indicator because once it is already inactivated, we assure that these pathogens are destroyed up to the level to make a safe product. Now we go to discuss the 3 techniques of pasteurization. 3 techniques are 3 ways to do. The first one we call it batch or LTLT pasteurization. What is LTLT? Low temperature long time. Or if you skip this word, it's become my name, Lê Trung Thiên, right? Low temperature long time. We do at low temperature for a long time. And the conditions are 62 to 65 degrees C for 30 minutes. Why do we need this long time? We do this after or before filling, after before packaging, after. We do filling in the bottle, in the box first, before we apply the heat treatment. That is why we need this long time for the heat treatment to be sufficient. And because we do at long time, so we should do at low temperature. Okay. This is simple and cheap. You can buy like a heating tank like that. This can you heat the temperature maybe for example to 67 degrees C, and you can maintain this temperature. After doing filling a packaging into the bottle, you put the bottle, you submerge the bottle under the hot water, and you maintain for 30 minutes, and you take them out, you do the cooling, and you have the product. This is cheap because this instrument is quite cheap. It's maybe 15 million only. You can cook, heat the water, and you maintain at this temperature. Nowadays, if you go on the street, you see how people cook the broth to make phở or bún bò and so on. They use also the heating tank, similar. Also can control the temperature to keep the broth hot for whole day. Okay, but this technique is rarely applied in developed countries. This is the conventional way. This is how Louis Pasteur did with his experiment in the past. Right. Simple. You can invest this to make pasteurized milk, to make pasteurized soya milk, to make pasteurized fruit juice and so on. Cheap and what? Flexible. Today you do this, tomorrow you do something else. The second technique to do is HTST. What's HTST? High temperature for short time. You can only do this before filling. Okay. Then you need a pump and you need heat exchanger. You pump the milk through a plate heat exchanger, for example. We will see the image of a plate heat exchanger later on. Then now we do at higher temperature, 72 to 76 for 15 to 40 seconds. Remember again, after filling, if you do for a short time, you cannot do. After filling, you cannot do HTHT. You need to do long time for the heat to transfer to give a proper heat treatment And because you already do long time, and you should do at low temperature, otherwise you destroy more nutrient and sensorial quality. And the third technique is flash pasteurization. Flash means ultra fast, very fast. Like when you take a photo with the flash on, you just flash. The condition are what? 85 to 90 degrees C, almost 100 degrees C. And the time now is only 1 to 4 seconds. Do we do before or after fueling? Before fueling. And do we need heat exchanger as well? Yes, we do with heat exchangers. The heating control is based on the peroxidase inactivation. So the indicator for this pasteurization is peroxidase. If you go back, you will see. Now, if you do HT, this condition 72 to 76 degrees C for somewhere here. Okay. If you do here, then it's 80 HT. If you do LT, then somewhere below here, and the time is here. Somewhere here, LT. And now flash 85 to 90 degrees C for only several seconds. If you do flash, pasteurization will be around here. Only the flash pasteurization now is at the right side of the inactivation curve for peroxidase. So only flash pasteurization then can inactivate all peroxidase. So the activity of this enzyme can be used to distinguish between flash pasteurization and other pasteurization techniques. Where is thermization? Thermization 60 to 65 for how long? 20 seconds somewhere here, right? Thermization here. Thermization should not inactivate phosphatase. Pasteurization must inactivate phosphatase, but thermization should not. Because if thermization inactivates phosphatase, then it is no more called thermization. It's already pasteurization on above. Does sterilization inactivate phosphatase? Yes, of course. Sterilization is much higher heat treatment. Right. You need to memorize by heart all the condition, the temperature and time between the three techniques, because you will see in the exam. What are the effects and product of pasteurization? Pasteurization gives only small, minor changes to the nutritional and sensorial characteristics of milk. This is positive or negative? Positive. When we drink pasteurized milk, the flavor is quite original. Nutritional value is high, still high. We do pasteurization, we lose some volatile components, but this is also good. Like we make the kind of blender more homogeneous in flavor. There is no measurable effect on the color of milk, so the milk color is still maintained, not become brown, but still white. After homogenization, the milk become white. The loss of vitamins is also limited. All these are positive or advantages, but we have also a big disadvantage for pasteurization, is that the extension of the shelf life is short or long? Short. And by a few days or up to a week, not so long. And this is a disadvantage.